In previous videos, I had showed how to construct histograms from some data. And here we'll look at 4 common types of probability distributions. The first type is the rectangular distribution. This is where all observed data values occur with the same frequency. And a classic example of this would be rolling a 6-sided die many times. So let's say, for example, that you had a truck full of dice. And you go around and record which face of every die is up. You put the results into a frequency distribution and then graph the histogram. What would you expect it to look like? Well, I have a simulator here. Here's one from academo.org. We can pretend that we're going to roll many die. Alright, now first, I'll just roll a single die. Now the first time we roll a die, we don't know what number is going to come up. In this case, it was a 5. So we put a bar at 5, representing that that face had occurred in the past. Now we're going to roll it again. And as we roll it, as you can see, different numbers are coming up. This time we got a repeat, 2 3s. And as we continue to roll, there are going to be more and more repeats. And you can see what's happening here over time is that eventually all the different numbers are going to occur many times. Okay, now I'm going to put it on automatic mode and let it continue on its own so that we can see what the bars are trending towards. So after 6,000 rolls, we can see that each face of the die 1 through 6 occurred about 1,000 times. And the distribution is nearly perfectly rectangular. If we were to continue this experiment more times and let it go toward an infinite number of rolls, then the distribution would approach a perfect rectangular shape. Another type of distribution is the bimodal distribution. This happens when 2 non-adjacent data values occur more frequently than others. A common example would be the heights of humans. So, sexual dimorphism is a common phenomenon in biology, where the sexes will display different average characteristics. So we may have a peak for male heights and a different peak for female heights. And the male average may be around 5'6", which would be 66 inches. And the female average could be 5'2", which would be 62 inches. Now, of course, this doesn't mean that every male is taller than every female. We can certainly have females that are taller than males. But what we're looking for is the average around which most females and most males fall. And those would be these peaks right here. A skewed distribution is similar to the normal distribution in the lower right, but it doesn't have symmetry for a particular reason. So a common example here would be the number of children that a couple has. Now certainly there are a lot of couples with no children, and there are even more couples with one child. The most common number of children to have would be approximately 2. You can have more than that, but it's not as likely to have 3 children as it is to have 2. And so the height reflects how likely these things are to occur. And you can certainly have more than 3 children, but the likelihood of that happening goes down and down the more children we're talking about. And then that brings us to the normal distribution. So in nature, normal distributions occur all the time. And these are symmetrical distributions, and that is where there'll be one value that has the highest frequency of all, around which most of the other data will fall. The curve is bell-shaped, so the farther away you get from the middle, the less likely it is for those values to occur. Let's check out these situations at the bottom and see what type of distribution we would expect to find. I already answered the first one. The results of rolling a fair 6-sided die an infinite number of times would be expected to be rectangular. The results we expect to get from rolling a fair 6-sided die a large number of times would be a rectangular distribution. It's because the outcomes on a fair 6-sided die are equally likely to occur. If it was perhaps a 10-sided die, then the numbers could look something like that. And this would show that they all occurred with equal frequency. A skewed distribution is expected for the number of children per family. How about the number of hours of sleep a person gets? Now, we're not talking about just one night here. We're talking about a large number of nights and keep track of what happened. Now, some nights you don't get a lot of sleep. Maybe you got to get up early in the morning. But other nights you may sleep in and get a lot of hours of sleep. But most of the time you get a similar number of hours. And so this would actually follow a normal distribution. That would be the bell-shaped curve. Sometimes you sleep in, sometimes you can't. But most of the time, you're going to get some average number of hours of sleep, maybe 8 hours, if you're lucky. Okay, for the heights of all humans, that would be expected to be bimodal. It would be normal if we were talking about just one sex, okay, like just males or just females. But if we combine both sexes together and take data on their heights, then we would expect 2 peaks that overlap. The wear-out mileage of a given tire model, that would be normal. If you're lucky, your tires will last longer than average. But some tires will blow early. But there would be expected to be a range around which most tires would tend to wear out. Finally, a scientist making repeated measurements in a lab